Hello everyone and welcome back. So I wanted to show the smoke sim and what we're going to be creating, and then we're going to go back and look at the various steps. So what I have here is 5 clusters, and the way I've divided it is I took the circle and split it into 4 like we did with the fire, and then deleted everything at the center, and that's going to be my 5th cluster. And this way I can have either a separate individual sim for the spaceship if I needed extra control, or I can have it part of the system and just be able to increase the resolution. So what this means is, if I look here, I have basically 400 by 300 or 1.8 billion voxels. 1.6 million voxels, and the resolution is quite high. If we combine all of these, it's gonna result in a super large resolution. So maybe about 2000 by 2000, which is gonna be impossible to sim. So that resolution will probably take 256 gigabyte memory and will take a lot of time to sim. But with this approach, I can easily iterate over it. I can increase the resolution of these individual elements, and it's going to be much faster for me to work with. So here's the final sim. It's reading in the viewport at the moment. I'm going to go to a different frame. And this is what the smoke sim is doing. It's getting slower towards the end because more data is being displayed in the viewport. And then that's the spaceship in the center. And the main difference between this and the fire is that the fire sim, I used the original RBD, but for this one I needed to make a few tweaks to account for the high res or the up res section that we did. And I should have used the same SDF, but I did it at different stages, so I have a separate collision for the center, which only contains the uprise segments, and then a segment, and then the remaining parts is basically everything else at its original resolution. So this is the preview of the smoke. And I think, yeah, I have another capture. Let me find it. Okay, so this is a preview of the smoke element with fire. And you can see there is so much details in here. Okay, and this is an older test with the smoke element where the smoke element has higher temperature, so it rises more. It's the same sim, but it just it rises more. So let's talk about this. So what we need is few things. We need first the geometry emitter, which we have done previously when we cached out the points or the volume. So this data. So this is the data. And right now it only has, well, it has no, so this only has the part where it doesn't have a pres. Okay, so only the surrounding part. It's the same, but I deleted the center part, and then I have this one for the center only, because I needed to create the emitter from the up-res version to make sure that I capture all the details. Okay, so I'm going to use this one to emit the 4 clusters. Let me show. So this is the 4 clusters, 1, 2, 3, and 4, and then I have another one for just the center. Okay, so what I've done is we've cached out the velocity and density. right? And I needed to scatter points because I need to divide this into meaningful segments. But when we scatter points, we lose attributes. Okay, so what I've done is I've transferred back the velocity from this, because in this example I need the debris trail to keep whatever velocity data they have in the points. So I'm using an attribute from volume to restore back the velocity field, and that's my data. Okay, so then it gets split into 4 segments, and that's my clusters, and this is the 5th cluster, which is only for the uprest segment, and it's the same thing happening. Lowering the velocity here because I didn't want it to shoot too far, so I'm dividing it by 50%. Okay, so what we need for this is we can do 2 things. We can either emit using the new combustion model, we can either emit density and flame and then tweak the combustion model to give us temperature, flame, expansion. But I didn't want to go that route because this is not an explosion. I don't need to engage the combustion model. Okay, so what I've decided instead is to simply pass in the density and the temperature and custom velocity. And with this, I can easily get smoke following any RBD object. And then with the temperature, we can inject a little bit of temperature in the beginning, which will cause the smoke to move in an interesting way. So that's the main reason. The temperature is to introduce more swirls and more movement to the smoke. Then I noticed after a while that I'm not getting enough smoke as the pieces comes off, or as the sim just evolves. I'm not seeing enough expansion. It was just very low in density. It's not filling in enough space. So the hack for that is to inject divergence. Okay, and divergence will cause the sim to expand, and we can control that. So what I've decided to do is take the same temperature field, because it only lives for it only get injected briefly, and I copied that same information to divergence. So every time a new emission happens, the smoke will expand a tiny bit in the beginning and then drops off. So this is basically a hack, and it's gonna be faster to work this way. So okay, let's set this to 0. So this is my emitter, and let's pick an interesting segment. So pick this one. Yeah. And I'm going to create a density field and a temperature field, and they both have a value of 1, and then I add noise to them. And let me visualize this noise. I'm going to use a color node. I'm going to say ramp from attribute, and this attribute is density. So my density has this randomization, so it's not uniform. And also my temperature is the same in this case. They are both exactly the same. We can use different nodes for each and lower maybe the frequency or the noise of the temperature if we want to get more variation, but this worked for me. And then I'm simply rasterizing this. So we have density, temperature, and velocity.